Welcome back to 7.3 Part 2. We were just finishing up our example number 2, and I was about to say when our video ended there that leaving our answer like this seems a little troublesome, having a square root under a square root, but this is truly the best that we can do given the circumstances. Our half-angle formula answers are always going to look a little messy like this with radicals underneath radicals, and that is okay. All right, moving on to the next example, we're going to use a half-angle formula to find the exact value of tangent of pi over 12. And again, I think that this is easier to find using degrees. So we could take pi over 12, multiply by 180 over pi, but if pi over 6 is 30 degrees, then hopefully it makes sense to you that pi over 12 would be equivalent to 15 degrees. All right, so tangent of pi over 12 is equivalent to tangent of 15 degrees. So just like we did before, we need to think, what is 15 degrees half of? And we already know the answer to that question. It is 30 degrees. So I am going to think of this as tangent of 30 degrees divided by 2. So that 30 degrees is the x value that we're going to be plugging in to the tangent of x over 2 formula, right? And I am going to be using the sine x over 1 plus cosine x. Either one will work, truly doesn't matter. That's just the one I like better, okay? So when I plug it into the formula from the top of the page, I'm going to have sine of 30 degrees in my numerator, and I'm going to have 1 plus cosine of 30 degrees in my denominator. Sine of 30 degrees is 1/2. So I'm going to erase that so we don't get confused here. So sine of 30 degrees is 1/2. And cosine of 30 degrees is the square root of 3 over 2. So now I have one of those fun denominators where I know that my next step is going to be that I will need to multiply by a conjugate, right? So first, before I do that though, I am going to take a look at how I can simplify this just a little bit, okay? And one thing that I can do, which is just going to make the math a little bit easier, is I can multiply, in order to kind of simplify my complex fraction a little bit, I can multiply the top and bottom by 2, or 2 over 1 times 2 over 1, okay? So that's going to make my numerator 1, and it's going to make my denominator 2 plus the square root of 3, okay? And again, I just multiplied by 2 in my numerator, and I multiplied by 2 in my denominator. Multiplying by 2 over 2 is just like multiplying by 1. So I'm changing the way that this expression looks, but I am not changing the value of it. And now it's much simpler to work with. So now I can think about multiplying by our conjugate to simplify the denominator and get rid of that radical. And remember, the conjugate means we just change the sign. So the conjugate to 2 plus the square root of 3 would be 2 minus the square root of 3. So I'm going to multiply top and bottom by 2 minus the square root of 3. When I do that, obviously in the numerator, 1 times 2 minus the square root of 3 is just 2 minus the square root of 3. In the denominator, 2 times 2 will give me 4. My inners and my outers will cancel, and square root of 3 times negative square root of 3 will give me negative square root of 9, which simplifies to negative 3. So I end up with, in the bottom, 4 minus 3 is just 1. So my answer is just 2 minus the square root of 3 over 1, or just 2 minus the square root of 3. The next two examples that we're going to look at are similar to examples that we did in our previous section, 7.2, where somebody has given us numbers plugged into one of our formulas. We have to figure out which formula it is and kind of work backwards, okay? So when I look at example number 1, It says 2 sine 37 cosine 37. Well, to me, that looks like 2 sine x cosine x, which is our formula for, sine of 2x, with x being equivalent to 37 degrees. So I know that in this case, sine of 2x would be equal to, keep messing up, sorry, would be equal to sine of 2 times 37 degrees. 2 times 37 degrees is 74 degrees. And in this case, 74 degrees is not a nice value for us on the unit circle. So we grab our calculator, make sure that you are in degree mode, type that in, and we should get 0.9613, rounding to 4 decimal places. In example number 2, we determine which formula this looks like, and this looks like the tangent half angle formula, tangent of x over 2, and in this case, our x value would be 20 degrees because it's sine of 20 over 1 plus cosine of 20. So in this case, tangent of x over 2 would be equal to tangent of 20 degrees over 2, which would be tangent of 10 degrees. Again, not a nice value for us on the unit circle, so we grab our calculator, type it in degree mode, and we should get 0.1763 rounded to 4 decimal places. The last formulas that we're going to be adding to our formula sheets are the lowering powers formulas. And these can get a little bit messy as well. And just so you know, this might be an excellent opportunity for some extra credit on a quiz or a test, okay? So I'm probably not going to ask you a lowering powers formula as one of the questions, but I might ask it as an extra credit question. So it's definitely worth practicing a few times in the bookwork and, you know, maybe redoing this example a few times just to make sure that you're comfortable with it. So what they are asking us to do here in our last example is to rewrite the given expression cosine x to the 4th power in terms of the first power of cosine using the lowering powers formula. So obviously for this particular example, we're going to be looking at this formula right here. Okay, we're going to be using the cosine one because that's what we were given as cosine in the original problem. Okay, so the first thing that I'm going to do, because my lowering powers formula is for cosine squared and not cosine to the 4th power, is I am going to rewrite cosine to the 4th power of x as cosine squared x times cosine squared x. And once I have that, then I can do a substitution with my lowering powers formula. So each of those cosine squared x can be written as 1 plus cos 2x over 2. Okay, but keep in mind that I'm going to have 2 of them, right? So I'm going to have 1 plus cos 2x over 2 and 1 plus cos 2x over 2. Well, that looks like a multiplication problem. If you ask me, I'm multiplying 2 fractions together. Well, the bottom is easy. 2 times 2 is 4. Okay, but when I multiply the top, I have to FOIL 1 plus cos 2x times 1 plus cos 2x. And so when I FOIL that out, what I get is 1 times 1 is 1 plus my outers give me cos 2x. My inners give me another cos 2x. And then my lasts, cos 2x times cos 2x gives me cos 2x squared. Okay, be careful how you write that. Note that I put the 2x in parentheses there, okay? So the problem is, now that I've done this, I've introduced another cosine squared expression, which means that I am going to have to use my lowering powers formula again, right here. But be careful, my x value, and I'm saying x in quotation marks, is actually 2x. So I have to be very careful about how I plug that in. Let me show you. So my numerator is going to become 1 plus the cos 2x plus the cos 2x. There will be 2 cos 2x plus, and now I'm going to use the lowering powers formula. So it's going to be 1 plus cos, but 2 times my x value is really 2 times 2x, which is going to make cos 4x, and that's going to be divided by 2. That's all in the numerator, and this is all over 4. So now I've kind of got a gross complex fraction. The precalculus here is done, okay? The next part is just algebra. I'm actually going to work further over here on the left. So I've got, whoa, yikes. Hang on, let me erase that here. Okay, I've got 1/4 plus, now the 2 cos 2x over 4 can become cos 2x over 2, right? Now those 2's can't simplify because the 2x is inside of the cosine function. Plus, okay, then I've got, in the numerator I have 1/2 plus cos 4x over 2, okay? So the 1/2 divided by 4 becomes 1/8. Again, this is just algebra. And then I've got my cos 4x, and again, I'm going to put the 4x in parentheses so I remember that that's inside the cosine, and that is also divided by 8, okay? And then perhaps the last thing that we could do here is combine like terms. So we've got our 1/4, and we've got our 1/8. So if I turn 1/4 into eighths, that would be 2/8. So 2/8 plus 1/8 gives me 3/8. So my final answer is going to be 3/8 plus cos 2x over 2 plus cos 4x over 8. And I suppose you could make a common denominator of all 8s by changing your middle term and then putting everything over one denominator. That's not necessary for me, but you could certainly do that. So I'll show you what that would look like here. Okay, so it's this, or it would be 3 plus. Now if I'm going to change this into an 8, I multiplied it by 4. So I would have to multiply my numerator by 4 too. So this would become 4 cos 2x plus cos 4x. And then this would all be over 8. Okay, so that would certainly be another way to write your answer. So either what I had in the purple before I modified it with the blue, or what I have here in the blue. Both of these would be correct answers. And that's the end of section 7.3.